Hi, my name is Christopher J. Watson, and today I'm here to present to you, ta-da, the server logic controller for the ROBOTIS labeling robot. Boy, is that a mouthful. But what does that all mean? Let's start with what a server is. What is a server? Well, I don't know what you all think. Maybe you're thinking of a big rack of computers, maybe you're thinking of the cloud, maybe you're thinking, I don't know, because you've never dealt with it, and all of these answers are fine. Um, For our project, we used this, believe it or not. It's just a little itty bitty computer. Now, before I talk to you about this computer called a Raspberry Pi, let me make you a simple analogy. You go to a restaurant to order food, and the server comes, takes your order, goes to the kitchen, and brings you back the food you ordered. He did the job of a server. He takes requests and fulfills them to the best of his ability. I mean, maybe they might not serve pizza at a hamburger restaurant, so he can't bring you that pizza. And that's just the limitations of that particular server. Well, same thing here. Our Raspberry Pi has its own limitations, and we'll talk about some of that. But for all intents and purposes, the camera is the client. It tells the Raspberry Pi, hey, there's a box over there, and I want you to pick up a label and move this far and put the label on the box. The server says, okay, how am I going to do that? Figures out how it's going to do that, tells the arm, or it says that it can't do it. All right, so I guess the next question some people might be asking is, how? Well, as we said before, we have this little computer called a Raspberry Pi, and it can hook up to the internet like any other computer. You can hook up monitors, keyboards, mice, cameras, and it takes all of this like a normal computer and it's running a program that acts as the server. And what it does is it makes socket connections. Now, I'm not going to explain in this video because it would take way too long how TCP/IP and socket connections work, but basically, over its internet channel, whether it's plugged in or wireless, it creates a tunnel between itself and the client computer, which has the camera. Uh, and they can talk through this little tunnel. That's the socket connection. It's a little tunnel where they can talk to each other safely. And basically, as they're talking back and forth, the camera is giving instructions of how far away this box is from the robotic arm. The server then takes those instructions and does a few things with them. It uses a state machine to keep track of what it's doing. Now, all a state machine really is it says what I've done and what I can do next. Let's say, for example, you're coming home, you open the door, you go through the door, and you shut it. Now, to know that you need to shut the door, you have to know you came through the door, that you opened it, right? Um, you wouldn't just, or if you're coming home, you know that you have to open the door first. You don't just walk and expect the door to open yet. Maybe that'll happen in the future, but you would just slam right into the door. Well, this is what the state machine does. It says, all right, these are the actions that you can do, and this is what you did. So the state machine on the Raspberry Pi basically takes the input from the camera that says how far away we are from the box and says, all right, am I at home? Home is its safe position where it just rests and waits for commands. And if it's at home and it's given a position by the camera, it says, okay, I'm at home. I need to go get a label first. So it goes, moves, picks up the label. And then it goes to the position because it remembers that the camera told it about. Now, once it moves over to the position that the camera told it, it asks the camera, it says, am I in the right position? Because I want to make sure before I drop it. And the camera can either say no, and it'll try again, or the camera will say yes, and it'll put the label on the box, and then it'll go home. Very simple. But in order to do all this, it needs a state machine that tells it what its courses of actions are and what it did or where it's been. Um, so that's how basically the server works is it receives these connections from the camera and processes them using socket connections in a state machine. Now, what does it need to do its job? That's a different question. Well, first of all, it needs the motors, right? But it needs to be able to talk to the motors. So it relies on controller software that our um, controller software team developed to move these motors. It sends commands through the pre-made functions. It says, all right, I calculated that I need to move to these angles. Um, so I'm going to tell the motors, hey, move to these angles. And it does it through these pre-made functions that our motor controller team made. If you want to know more about that, you can go watch their video and they'll explain it. But it sends these commands, and then it also needs, of course, the camera. There are many ways to say, okay, go pick this up. Like, as you know as a human, maybe you just know where it is from touch. Maybe you hear something coming, so you reach out your hand. Or maybe you see it and you reach out to pick it up. And that's the way this robot arm works, is it sees an object and it reaches out to touch it. So it needs the camera, it needs the motors, and it, of course, needs these inputs that it's getting. With all of that, it can do its job, which basically is coordinating the whole effect. I hope that you gained something from this video, and I hope this was interesting enough that you go see all of our other videos. Thank you very much.